Hey everybody, welcome to the Hump Day Hot Tip for SolidWorks for this week. Last week we talked about capping off a surface or a closed shape using, in last week's case, a revolved surface because we were working with a conical circular input, which meant that a circular surface, like a revolved surface, would work fine. Now, as we mentioned last week though, we always want to use the simplest possible solution from a geometrical standpoint. Revolved surface is an extremely simple surface, which makes for beautiful, smooth surfaces. They're just perfect. The problem is, of course, that in a case like this, where we're working with what industrial designers lovingly call a squircle, it's not going to match up. We're not going to be able to get there using a revolve. Now, this is a very popular type of shape for industrial designers, so this is definitely a situation that a lot of folks are going to want to pay attention to because this is a very common scenario when you're designing modern-day products. Like, I don't know, the old iPhone, those were like that. There are lots of products that still have this kind of shape. So what do we do to deal with this? Well, first of all, I would say we would next look to a swept surface because that's the next least complex surface available to us after revolve. But unfortunately, that one's not going to get us there. There's just no way to make that work in this particular scenario. Hopefully, we'll come back to that in a future video. But really, we need to jump straight on up to the lofted surface at this point. Now, loft and boundary surfaces are very, very similar, and we're going to kind of tease that apart a little bit over the next couple of videos. But suffice it to say, there's a reason why both of them are still here. Many people assume that because they're so similar, really you should just use a boundary surface all the time. That's not true. A lofted surface will make a simpler, cleaner surface than a boundary surface in many situations. So today we're going to deal with that one. Now, before we go there, though, the next step would be to create a curve, and I want to get there by way of teaching you another little trick. So if I select a sketch in the tree, note I'm not selecting it out here in the viewport, but I'm selecting it in the tree, and then Control-click on a plane, I can head up to Insert, and down to Derived Sketch. This is a very little known tool here in SolidWorks. Actually, very few people know about it, but it's really, really useful. Essentially, we've created another sketch that contains the contents of the original one, and these ones actually can't be changed. I can rotate it and move it around. I can even constrain points to lock them down. So I could constrain that point to that one and constrain this point to that one and lock them down. But the actual shape is always going to be exactly the same as the original. And even if I go back and update this original sketch, the other one will update too, which is very, very sweet. Okay, so nice little tip for you. Definitely make use of derived sketches. Now we have enough geometry here to create a loft. So let's go to our lofted surface. And there are several ways that we could do this. The cleanest, in my opinion, would be to go to loft from here to here. And that's going to give us a clean, straight loft. Now I want to make a note here. When you're creating a loft, let's clear this out. You want to click on the same side of the curve. So if I click here at this end of this curve and then click here at this end of this curve, things are going to fail. That's because it's trying to basically twist the surface around so that this point connects with that one. You can see with the green connector lines. That's going the wrong way. To fix that, I can drag that connector to the other side, and then we'll get the correct result. Okay, so once you have your cheese wedge here, just head down to the guide curves area, and we'll just drop in this edge as a guide curve, and voila, we have a surface that achieves pretty much what we want. Now, not quite though, because if we look at this from an angle, you'll see that our continuity is lost along this shoulder. So to fix that, we just select that guide curve here, head down to the tangency properties, and set tangency to face. Hit OK, and that should give us a decent result. Actually, the result should be quite good. So if I turn on my zebra stripes, you'll see we do have nice, clean tangency continuity. This stripe is coming over and meeting with this one perfectly. It's not curvature continuous, but it's pretty good. Now, we don't, in the lofted surface, even have the option of creating curvature continuous lofts. And we'll save that actually for a separate video. But if I delete this loft for a second here, do note that these guys are conic curves, right? So if I actually take these and switch them out for, say, a spline, for example, then I could get this to be something much closer to curvature. In fact, we could get curvature continuity here, just not so much in the middle. Let me show you what I mean. Instead of grabbing an old school spline, this time just for fun, let's use our new style spline, new as of SOLIDWORKS 2014, and I'll just start dropping in some points here to create a curve and snap that in to end it. I'll delete that original conic, get that out of the way. Let's take this input here and control-click this one. Let's make those collinear so that we know this is tangent. And also, I'm going to make these two collinear so that we know that we've got nice curvature continuity from one to the next. Okay, so that should do it. Now let's make sure that these guys here are collinear so they don't get all messed up. And let's look at our curvature combs and make sure that we're getting what we want here. That looks pretty good. Now, right now, this is merely curvature continuous. We can see that our radius does go down to 0 here, as it should. If we wanted this to be G3 continuous, then we would want to align a third point. So let's take this one, control-click this. Let's make those collinear as well. And now we have the ability to really drag this out. Let's make this nice and extra super-duper smooth. And now we've got extremely smooth curvature here. Need to make sure that this one is horizontal in order for this to work. There we go. So this is now a super baby butt smooth curve. Hit OK, and notice that our Derived Sketch has updated. Beautiful. We didn't have to change that. Derived Sketches rock. And we'll go to our Lofted Surface. Once again, we're going to loft from here to here using this as a guide curve and set that input to tangency to face. Hit OK. And the result is quite good. Let's turn on our zebra stripes. And at least over here on the edges, we are getting better continuity. It's smoother. You can see that the zebra stripes are casting more smoothly. It's hard to tell that depending on the angle. Over here, you can kind of see it. But in the middle, you're never going to quite get there. Now, the more discerning among you may know that we do have a slightly different way that we could do this. Let's delete this. So we can always head up and run the boundary surface. We're going to talk about this in future videos, but the result is basically the same. I'm going to select these two just like I did before with the loft. And this time, instead of guide curves, we use what's called direction to, and select that. This is going to allow us to choose curvature to face instead of tangency to face, and hit OK. And let's turn on our zebra stripes, and we'll get slightly better results all the way across the board. Now, really discerning surfacing types will know that this is still not fantastic. These zebra stripes are not as nice as they could be in a real surfacing package, like Alias or CATIA or NX or those kinds of things. You'd be able to get a much better result there. But as for SOLIDWORKS, as far as SOLIDWORKS goes, this is pretty decent, and probably as well as you can do. Now, one more little note, you may also realize that just like revolved surfaces, these are going to have degenerate points in them. Let's actually go back here, turn off our zebra stripes, and turn on a curvature point, and you'll notice that, whoa, we are getting some gross stuff starting to happen here in the middle. Now, this is very, very flat geometry, so really these changes in curvature are not going to make a huge difference in terms of the visual effect to the surface. And like I said, these days machining software can generally handle it pretty well. It's not going to create chatter like it used to, or sometimes toolpaths would just fail entirely in the past. These days, it's going to smooth out. It'll work just fine. So I would say that in general, this surface is pretty decent. If we don't like it, we can go back to our Lofted Surface, try that one instead. Let's see what that looks like with our curvature turned on here. We'll make that tangency to face again and hit OK. You can see that the result is cleaner and simpler. We are getting some weird stuff around the edges, but that's probably just par for the course in dealing with this. We could go back to that and look at the start and end constraints, make sure those are normal to profile. That should give us a little bit of push on either side of those that could make this a little bit smoother. But you can see that this is pretty much as good as we're going to get here in SOLIDWORKS, unfortunately. So that is that's it here, folks. Now, I have talked about how to make these even smoother here on CAD Junkie before. If you look up pillowed surface on CAD Junkie, you will find several videos pertaining to this very topic and this very scenario, and you can make this even better than what I'm showing right here if you go check out those videos. But for now, that is a perfectly good method, and next week we're going to talk about even more complex scenarios for working with capped ends here in SOLIDWORKS. All right, have a great week. We'll see you.